Hello, everyone. I'm Bertrand Cariou from Trifacta, and I'm with John Thomas Volpe from Alation. And so we'll be discussing today, first, maybe you don't know Alation and Trifacta and why we're co-presenting here. But in fact, we've been involved in numerous implementation where both our technology are used combined and used together. So we'll talk a little bit about our technologies and what we do, but also what we wanted to discuss is how because we are both software companies, how we've been developing our software with machine learning and in mind to solve complex problems using some algorithms to make it accessible to new kind of users or solve issues that were not possible to solve before using machine learning. So we'll go over. Also, the announcement is that I think a couple weeks ago, or 3 weeks ago, we announced a deep collaboration and integration about the two products. So we'll talk a little bit how we'll be integrating the two products together. And I think we'll go then over some demos of what we're doing. So to start with, Jen Thomas will present what Alation is doing, and then I'll be presenting Trifacta.
So just to quickly give you a little bit of introduction, Alation is a collaborative data catalog. And what we're really focusing on, especially in this space, is trying to enable the data discovery and curation of data across the enterprise. So if you think a little bit about what users have to go through to get to data within any company, especially as big data advances, it's a pretty daunting experience. There are many places you could go. So you could go to Hadoop, a data lake, to go find data that's been ingested there. It could be a data mart or a data warehouse that has more structured data but has been in there for a long time. You don't really know what's fresh and what's not. Every department definitely still has their own spreadsheets where they curate their data, and I'm sure there are extracts living in BI tools all across the organization. So you could go to all these different places to find the data itself. That does not mean that even if you do find data, you'll be able to use it. You're going to need some level of trust in that data to have numbers that make any sense. So you'll start going through the logical layer and trying to figure out, are there any wikis that talk about this? Or if you send an email to say, hey, do you know where this data lives? How do I work with this data? And before you can look at glossary terms and maybe sometimes even source code to decide what you should be using. So it's pretty overwhelming. It's a lot of different paths you can go down. It's very time consuming. We asked our customers how long that takes, from day zero to getting to productionizing an insight. And 40 to 70% of that time was spent finding and understanding the data. So it's pretty significant. And that complexity leads to tribal knowledge and silos within the organization. It leads to people just working on what they know and what the people around them know, which is the opposite of a data-driven culture. You should be letting the data lead you to the next question, not be limited by the data you have and only ask questions that you know it can answer. So really that's where a modern data catalog comes into play. So it's about not only giving you an inventory of what exists, which is what traditionally a data catalog would do, but also extending that with context. And that's where machine learning and smart ways of suggesting information really help out in making sense of all of the information throughout the company. So these are just some examples of modern data catalogs that have all innovated on something from the past, a kind of catalog from the past. And they've done it in ways that represent three characteristics I think are particularly important in bringing value to the organization. So TripAdvisor, if you go on a trip today, you'll probably look up a restaurant, a hotel, and find out what is a good place to eat or what is a nice place to visit. 30 years ago, you couldn't really do that. You would either talk to your friends and see if anyone's been to that town before and say, what places did you like? Or maybe a travel agency would give you a recommendation or a book. You were constrained by the information you had at your hands. You couldn't tap into a larger community of people you might not know. So we focused in on how to make that broader community across the organization, whether it's in your group or not, to help you find the data you need and help you understand how to use that data. You also need to be able to trust that information. So just like LinkedIn allows you to quickly find out who's in your network and who you might know in common so they could give you a recommendation if possible. We want to be able to tell you this is the data you can trust. Here are the people that use it. And based on who they are, that can give you a degree of information on what you might want to do with it. And just as importantly, it has to work at scale with growing data volumes. If you think back to the early days of the internet and Google and Yahoo trying to create directories of web pages that didn't really scale, right? Google tried the other way around. It's a bottom-up approach of saying, let's index everything on the internet and then figure out through patterns of how people were linking across web pages what is most relevant, what is most valuable. So having the ability to go out and getting information on all of your data sources is key to doing this successfully. So in tapping into the knowledge of the entire organization, there are a couple different areas that are particularly important and where the machine learning and the smart piece comes into play. So we make sure that you have usage-based recommendations. We'll parse logs from the database to understand who is using what and how much is being used. So if there's a very popular table and you're looking for, let's say, revenue, you should probably start with the most popular table that mentions revenue. So we try to make that easier to find, easier to use. And we give you a place to kind of tap into that community. So you should be able to understand who an expert is and ask them a question in that same tool so that others can also learn from those questions and not ask the same things over and over again and help you kind of cross those silos within the company. And at the same time, be able to access any glossaries or wikis that are relevant to that data. So we try to figure out, if you talked about this data set in this glossary, you should be able to find it on the catalog page for the data set as well. So we make those links to make it easily accessible. And in trusting the information you get, we want to look at again, those logs to understand who is querying the data. Just knowing who across your team or across your organization is executing queries against a table reveals a lot about the data itself. So if you have a person that is doing financial reporting for the company and they're building BI reports or running queries against a certain set of tables, it's likely that that data is probably good quality because they're not going to be presenting that to shareholders if it's not. Whereas maybe an analyst is going to be doing some sandbox development and they're just playing around with the data. So it gives you an initial point of information that you can then take and expand into a conversation within the tool. Also being able to track the lineage and propagating down that lineage any issues with the data. So adding annotations and flags, but then also passing them downstream to a BI report that could be affected so that people across different environments, whether it's the development environment or the analytical community, can consume that information no matter where they sit in the pipeline. And that ties directly into the ability to add those annotations and flags. So having the ability to come in and review the data to a certain extent and say, I endorse this, I certify this, or I'm deprecating it. I don't think it's something that people should be using. So having that kind of community approach to that is pretty valuable. And in doing this at scale across the environment, we have focused in on taking that popularity, those rankings, and the annotations, and using them to help you find the data that's most relevant. If you put in a keyword and you get 1,000 results with no sense of difference between them, that does not really help you. It creates more work. So we'll be looking into both the physical layer of the metadata, whether it's in Hadoop or a relational data source, but also the logical information that's associated with it. So titles, descriptions, and the usage information to help you get to what's most relevant. So we can differentiate and create a real ranking that makes sense and helps you get to what's most useful first. And we'll also look at the patterns in the way you are documenting data. So if you keep on calling a column there shp_dt, ship date, maybe it's been titled somewhere else, we can learn from that and start making suggestions in other places where we see those abbreviations. So we can expand the natural language piece and scale up your efforts around the documentation. And the whole catalog is maintained in a very automated way so that people can focus in on the curation rather than registering assets manually. So again, it's that bottoms-up approach of saying, connect to the data source, extract the metadata, refresh it on a scheduled basis, and then let humans add the qualitative content around it to make it more useful to others. So that's kind of the introduction of what Alation is doing in this space and why we think it's particularly important to help you find that data and get value out of it. I'm going to pass it back over to Bertrand to talk a little bit about what Trifacta could do once you find the data.
Yeah. So first phase, so if you're putting together a data lake, data hub, who is doing currently initiatives? Okay, so you're bringing, the first phase is usually you want to ingest the data in the lake. So this one is pretty well known. There are technology for data integration, data ingestion. However, then the next phase is to know what is available, how it's been used before, or even, yeah, it could be in the lake, but the data that may not be yet in the lake could be also indexed and unknown. So then you know that you need to bring it. And then if you stay there, okay, you can find the data, you can figure out what data is available and the quality, but then how do you start using that data? And you may want to combine a data set from here with a data set from there, but they are not talking the same language. They're not combined. They're not standardized the same way. So it's where if you don't provide a layer to the end users where they can discover, manipulate the data, then your lake will be frozen. And it's where Trifacta comes into play. And what we do is providing to more analysts, line of business. Most of our users would be, I would say, people that are in the BI space. They're using Tableau. They're using Excel. We've got also users that are more data scientists. However, as Jen Thomas was mentioning, if you want to get insight from your data, you spend 80, 90% of your time searching for the data and then preparing the data, combining, cleansing, structuring the data. And it's over and over, it's what we hear. And Trifacta has been taking the, so to clean, to structure, clean the data. Very often it's been done by, I would say, ETL type of technology. So business people would ask, oh, I've got these requirements, please, can you bring me back the data in that format? You have to define the format, and then the IT people or data engineers will create a schema, load the data in, and then you would start seeing the data. So that's not really relevant with the volume of data and structured data. ITs usually have a backlog of projects they can't deserve. So the idea is to bring all that work of preparing the data to the end user, to the people who would know the data best. And so Trifacta has been taking an angle to shrink that time to usually 20% by applying machine learning to our software so that you don't have to be technical at all to do this work of cleansing, structuring, normalizing the data. So Trifacta has three key characteristics. So it's very visual, meaning that usually you don't want to code. You want to see your data. You want really to interact with the data visually. You want to know what is the value distribution. Is it a date? Is it a valid date? What are the outliers? You want to have signal about the data so you know if it is clean or not and how you can combine it with another data set. It has to be interactive. So let's say I've got invalid dates. I'm applying a rule to clean up the date, or I want to create a new calculation, a new metric, a new ratio. I define the rule, and I can see right away what the value is. I can try to join two data sets. I can see visually the data set, how they fit together. So it's very interactive, visual, and feedback to the user. Because otherwise, what you usually do is that, okay, I define or I code a rule, I ETL something, I R or I Python something, I run it, I look at the result, and I validate the result. So there is always this back and forth, and here it's immediate. You can see the result about what you're doing, and then it's scalable. So scalable means that it can run on billion rows while keeping this interactivity. So we had to think through it and create a product that could do that. So similarly to Alation, when Jen Thomas was mentioning Google-like type of thinking, our product is also similar. So when you start interacting with the data, Trifacta will figure out, okay, so you are selecting this portion of the data. Do you want to split? Do you want to extract that value? Do you want to create a new metric based on that value? So the product is providing some suggestion and also learning from what you're doing with the data. So the next time, the suggestion might be different. because the product is also learning. So similar to Google, based on your geolocation, if you're searching for some terms based on your industry, based on what you're searching, Google will be providing results that are more relevant to you. So Trifacta does similar things when you're cleaning data. So when I was talking about visual, first thing that Trifacta does and where we apply machine learning is that you can open, okay, Hive table, pretty structured, JSON, a weblog, less structured, XML, a CSV file, Excel file. You don't have to tell Trifacta what you want to wrangle or to prepare. Trifacta will figure it out. So that is where already we try to facilitate the work of the user, because you open a data file, we just open the data file in columns so you can see in the matrix the data. And then the next thing, we infer. So inference is also some machine learning algorithms that we use, or where, based on value distribution, based on different aspects of the data, we predict what type of data structure it is. Is it a date? Is it a social security number? Is it? You can create your own libraries, and based on that, Trifacta will validate. Is it valid data? Is it missing data? Is it outliers, so extreme values? So we give insight to the data that are the statistics. Also, we provide a pattern. So let's say you are trying to combine IDs from multiple data sources. And we can say, OK, that, like, it looks like a phone number, but also we can pattern the phone number with how it's really organized. So you can also have more insight toward the data to say, OK, I need to clean the data. These are invalid, and I know why. And I can define the rules to clean up. So that is the part that is pretty visual in providing insight. The next thing, and that is sometimes really surprising to our users, is that you start interacting with the data. So let's assume I've got a column that would provide a product size that would include the weight and the volume, and plus some text. And it's not really usable. So I would like to extract the volume and the type of and the size. First thing that I can do, I can brush over size and Trifacta say, OK, do you want to remove that part? Or I could select the space and say, do you want me to split? So Trifacta will provide suggestion. And then you can select the suggestion. And as you select the suggestion, that is the second tile here, you can see exactly what the result is. So visual feedback. And as I've got the visual feedback, the data is in real time is profiled. And so you can see the data errors. So you've got this interaction with the data. And then also, if you join two data sets, so Alation would suggest what are the data sets that are the most common. But then within the data set, what are the best columns to make the join? So also Trifacta will infer the best column to join. So these are, like, all this suggestion and interaction are helping the user to be very fast at cleaning and structuring the data. So we'll do both a demo of the two products. But in June, in fact, that will be fully integrated. So we look at the integration of the product. So we'll be exchanging through APIs metadata between our two products. So there is the logs, the API. And so Trifacta Alation are both connected to Hadoop, and also to the consumption layer, we'll be exchanging also the metadata. So if you are in Trifacta, so with Trifacta, when you import some data set, so you can connect to HDFS, S3, JDBC, and a 50-ish application we can connect to. And we'll add as one of the source Alation. So that will be the data catalog of Alation that can be searched. So I can search, and you'll see in the demo, that will be a demo based on one common customer, in fact, in Germany, that we are working on. And so in the insurance industry. So you can search in Alation. And when you are, so then you can search the data set you are interested in, and you can start wrangling the data, preparing the data that you search through Alation. the other way around. When you can start with the data catalog from Alation, find the data you're interested in, and then call Trifacta through Alation. So now they will take the data that is referenced in Alation and start wrangling in Trifacta. And the next thing that is pretty useful to all users is to understand, okay, where is the data coming from? Where are the source? Where is it is used at the end through a BI tool, data modeling. And so you'll see also the Trifacta wrangling as part of the whole lineage of the data pipeline. So that is pretty useful for any user to have a better overview of the data. It's also super useful if you're in a very highly regulated industry, banks, insurances, pharma companies, where you have to demonstrate and audit about the data. So we can show that also end-to-end. And I think we can go over the demo. So the demo will be based on a real case scenario. We can't name the company, but it's based in Germany, more precisely in Munich. And it's an insurance company, but I can't say more. It's about claim analytics. So the end user are actuaries, okay? And actuaries are very heavy using Excel. Are we switching? Or yeah, are you going to the? Yeah. So they're very heavy using Excel. Actuaries would have they have to analyze the claims, find claim exceptions, like claims that are been lost or non-processed. Payment, they have to also look at the forecast of payment. So they use what they call development triangles that are seeing over the years, maybe 20 years, what will be the payment for this claim. And they have to pivot the data. They have to combine the data set. And when the data is clean, they can also apply new models. And they can, so they're always working with data. And they used to do that with Excel. That is not scalable. And also, it's pretty risky to use Excel because anyone can enter something. So now they switch to, they have a data lake, in fact, where they bring all their transaction data in. And they use Alation to catalog all the data, and then Trifacta for all the wrangling.
Yeah. So for the demo, let's say I'm an analyst coming into the Alation interface to start looking for data that I could use for my analysis. So I don't know exactly where that data is. I don't really know how exactly to access it. But I can come in and in natural language, as we talked about earlier, start searching for data that could be relevant. So it will search across everything that's been extracted. It could be a schema, table, a column. It could be a business glossary. It could be the data dictionaries associated with the data. So I could come in and say I'm looking for professional indemnity. And it's going to start looking across these different data sources. So it's finding some stuff in the healthcare space. It's finding a couple schemas and tables in other locations. And I can filter it down to what I'm most interested in. So I could say I want to look at tables specifically. And I see something here around development triangle that looks like it has potential. So I can take a look at it. And you'll notice that the development triangle title, which is what showed up in my search result, is not the name of the table in the database itself. The name of the table is dev_try. But based on the titling algorithms and lexicon we have on the back end, Alation figured out that dev means development and try means triangle. So it's a pretty simple case, but it picked up on that and it made a suggestion. And the little robot head here is yellow because it's telling you a machine made that suggestion. And a user can come in and accept it and confirm it. If I'd said it was wrong and provided a different title, it would have fed it back into the system to make a new title suggestion in the future. So it keeps on learning that way. But as I try to figure out if this is the right data to work with, I can see flags have been added to the data. A little bit light up there. But there's a warning that's telling me that although this is endorsed by myself, actually, the warning itself is letting me know that this data set has aggregated data, and there are tailored views to actually look at it from different perspectives within the organization. But in order to calculate incurred claims and claim amounts, which are terms that are defined in the glossary here, I might need to do some data preparation and actually take a look at it that way. Oh, and I clicked by mistake. We can go back. So now that I know I can use it, I know I'm going to need to do some preparation, so I'm going to work with Trifacta later. But I'm going to first get a better sense of what exactly exists in this table. So I can see who the top users are based on, again, that query log ingestion. So if I have any questions, I know who to reach out to. And I can take a quick look in this Conversations tab to see if anybody else has asked a question on this. So somebody asked a question, the email got sent out, and a user answered back, and it comes back in here, so I can learn a little bit about what was exchanged or ask a new question. And I can dig into the columns that exist in here. I can see, based on the usage of that data, what is being used, what is not being used, as well as any keys that exist in the database itself. So it's helping me figure out that kind of lay of the land. It will also tell me a little bit about the kinds of filters that people typically use, the kinds of joins they normally use. So it's giving me an idea of how I might want to work with the data, as well as the lineage that's been able to extract on it. So here it's just simply going into a couple other views and temp tables, but it could go all the way down into a BI report like Tableau. And we'd have that lineage and propagate down any issues with that data. And just in case, somebody else may have already done some analysis around this that I can work with. I can see what queries have been published here. So I could self-serve, take a query like this, make my own version of it, or I could simply run it as is. But since there's still not enough information for me to do it myself, I'm going to see if there are any relevant articles, so any terms that have been defined here that are useful to this data set before I go and do the actual work of calculating those development triangles. So I can get a sense for what the loss triangle is. I have a summary here. It's telling me what data I'm going to need to work with. So it's showing me a sample of the data and where it lives. And I know also who the business owner of this term is, as well as a relevant data set to work with. So it's all linked, all in one place, all being shown wherever it is most relevant to an end user. So you can come in and work with it. So at this point, since the data needs to be prepared, Bertrand's going to kind of show you a little bit more about that and how Trifacta can help.
Thank you. So it's where, in the integration from here, I can directly wrangle. So you'll get to Trifacta. I have to connect, but I will be single sign-on. And so what I want to do out of that data is to create some ratio about what has been paid, what is outstanding payment. I want also to have like the development factor over time of the payment. So that is a way so I can get the money to pay, basically. So what I'll be doing in Trifacta, so Trifacta is composed of three concepts. What is called a flow. So data flow is all the rules you define to clean, structure the data, and create a pipeline to clean up the data. A data set is, as it's named, could be a physical data set, but also can be all the data where you that you have prepared and regenerating additional data set out of the preparation. And job is you can run the rules to clean up the data on top of Hadoop and Hortonworks like MapReduce or Spark. So when you've got a huge amount of data, all the recipe, all the rules to clean up the data is taken and pushed down into Hadoop. So in that case, I'm on my project, my data flow, and I don't have data in. So if it was coming from Alation, I could see the data already. So I can use data that is known in the lake, or I can import data set. Importing data set could be HDFS, Hive table. I can create new data set and connect. We've got something like 50 connections. In that case, few are configured. Or I can also upload my own data file. And very often, analysts would upload their own data file. Here, I've got in one data file. And it's what I was saying. So here, it's Excel, but it would be a CSV. It would be a JSON file. Trifacta will figure out. So it's uploading. And I can see all the tabs in my Excel, and I'm selecting all the tabs here to create my new project. So I've got the current claims, the claims from a previous month, and my development triangle over 20 years that I'll be using. So it's been added. So what I'm seeing here, let's go back here on my current claims. Here I can see the data as it looks like the raw data in Excel. And here it's already what Trifacta inferred to structure the data, discovered that there were headers. And that would be the same with any type of file. You've got the raw file or the raw data and how Trifacta infer through a recipe. So a recipe is in some steps like breaking the file based on the carriage return and then splitting the rows or in 40 columns, removing the double quotes and converting the first row as a header. This has been done automatically. But now what I want to do is edit this recipe and start structuring the data. So I'm opening the data set. And the next thing that you see is this grid where the data is represented in a familiar interface that is like columns and rows. But also you've got additional signals on top of the data. These signals are about the level of quality. So here I can see claim ID. Trifacta inferred was a string, and they are all valid, but I can say that I'm missing 14 values. Here it seems to be an integer. And if it is an integer, it seems to be always the same value, 14. Here, the third column seems to be a date. And here I've got also date, but I can say, oh, I've got red. I've got a date that is totally invalid. So it's already providing the end user, and you could be data scientist or you could be an analyst, and some signal about the level of quality of your data. So here, the next thing is that you start interacting with the data. So that is already data inference using machine learning to, and we've got algorithm about the files, the structure, and the columns. And the next thing then is I selected the missing values, and Trifacta is providing some suggestions. Do you want to keep these values? Do you want to delete? Are we seeing it well? Is it okay? Or you can read, or I don't know, definition. I may change maybe. If you can't see well, let me change quickly. Usually it works. Yeah, maybe for the people that are behind, that will be more visible. Here we go, it's bigger. So yeah. So the suggestion of Trifacta is keeping the rows, or do you want to delete the rows where it is missing? Do you want to create a new column? When it is missing, you say false. If it is not missing, it is true. So you've got all these suggestions. And I can select the suggestions. And based on the suggestion, Trifacta will also show me what it does on the data. And that's true. For some reason, in that Excel file, there are empty rows. So maybe the suggestion of Trifacta is to delete the rows, and I say add to recipe. So I remove these missing rows. Here, I can continue here. I've got like here, invalid values. I didn't like the switch to, let me try, yeah. So here I've got invalid values. I can select this invalid value. I can look at this invalid value. In that case, I can see that it is an invalid date. What do I do out of it? Maybe I can infer through a rule, if it is that value, convert to a valid date. Or maybe in that case, I can't do anything out of that. Or maybe I contact, looking at Alation with the owner or the people that are using that data the most, and reach out, hey, do you know what it means and how we could clean that? Again, in that case, I will get the suggestion to delete the data when the date is invalid. Looking at the other values, here I've got like a state. So if I've got also some menus, and the menus are also interactive. They're based on the data types, what's inside to suggest. And here I'll go to the column details. And I can see here the value distribution. I can visually see where the data is. And maybe if I select on a one data set and would say, OK, do you want to filter on text, on that state, or so you've got, again, some suggestion about what to do with the data. So here I will keep all the data sets. I'll continue. So that is, I'm still in the discovery. Discovery, initial cleansing of the data, claim type. I can see all my columns. And here I've got, OK, total recovery amount. And by the way, with Alation, that will say total recovery amount to get the long understanding here. And here it's, I've got invalid values. Let's look at the invalid values. And I can see the invalid values are, in fact, not integer, but decimal. So in that case, Trifacta inferred that was invalid because Trifacta was thinking it would be an integer based on the value distribution. So I could say, no, change that to a decimal, and now I'm losing these invalid values. So it's really a way to apply some initial cleansing and structuring of the data. So what I want to do now is to compare my current claims with the previous claim. So I will join the data set. So we've got a full language, and we can do like pivoting, aggregating the data, and that combining, doing time windows. And in that case, I will join two data sets. So I will join my current claims with prior claims, selecting the two data sets. I can preview the second data set. And the next thing also is we're trying to predict what are the best columns to match. And Trifacta said it looks like claim ID based on the type, based on the value distribution and the pattern are the best column to match together. So if you have to do the join between the two data sets, claim ID seems to be the right value. And I can say, OK, select all the data based on the claim ID, and now I would add to my recipe. So adding to my recipe, now I've got a large data set that would combine all the current claims with the, and now it added a 1, that is the previous claim. Just think about Excel, how people would do that, VLOOKUPs or whatever, painful. If you have to do that with R or other languages, you have to define the join, but you even don't know if the join is doing well. Here we can see the left columns, the right values, how it matches. So it's pretty good to have this feedback. And as I was going through, Trifacta has been also collecting every step that I'm doing to clean up and structure the data. And so this can be run at scale automatically. You say run job, and it runs on Spark MapReduce. Just to conclude, because we have like 3 minutes or 2 minutes, and maybe there will be a few questions. Now I can derive my calculation that would be a formula that, again, Trifacta will suggest. And maybe my formula, I want to have the paid amount minus so paid amount this month compared to the paid amount last month, and that would be my delta. And as you can see, as I'm typing, I can, on the right side, I can preview the data as it will look like if I'm doing my calculation. So here I can say delta. And also for the user, visual feedback, immediate, I know that's what I want to do. I want to make that calculation. Hide the recipe. I can do that again and again. If I'm not happy, I can change the recipe, go back, modify the recipe, change the order, and run the job on Hadoop. And when I run the job, or here I will quickly run the job. I can create a Parquet table, a Hive table file. And when the job is finished, then Alation is indexing the data. So it becomes a new information. And we know that that data has been created through a join between two data sets. And now it's run. I can go back to my flow, and I will conclude here. And now I can see that I also, visually, I can see that I joined my current claims with the prior claims. So that concludes, I would say, the value that Alation and Trifacta brings together in your data lake initiative. Any question? The question? Yeah, one question. Yeah.
Are these recipes going to be translated into Spark, so or iJobs and run on the Hadoop cluster?
Yeah, it's so for MapReduce, so we do pig, for example. So we push. We're totally. I'm not too technical, but we are integrated with Yarn and all the layers of Hadoop and also security layers. So we take the recipe, and it's converted directly and natively into MapReduce or into Spark to run at scale. So, but yeah, Trifacta we install on the node, so we can push the recipe directly on the Hadoop cluster. Any other question? So that would conclude the session. Thank you.
Thank you.